We're going to talk now about pulley systems as they're used for mechanical advantages. And specifically, we're going to address these 5 simple rules for a simple mechanical advantage. This is stuff that's been handed down over centuries through the mariner's industry. And they still hold true for today and are very useful in understanding these pulley systems. The first rule is if the rope is tied off at the anchor, it's always going to be even. It's going to be a 2-to-1, a 4-to-1, a 6-to-1, 8-to-1. Always going to be even. Here we have a 2-to-1. It's tied off at the anchor. Rule number 2 says if it's tied off at the load, it's always going to be odd. It's going to be a 3-to-1, a 5-to-1, 7-to-1. In this case, we have a 3-to-1. If I were to pull from right here, it would be a 3-to-1. Rule number 3 addresses this pulley right here. Rule number 3 states that the last pulley at the anchor, where the rope goes to the haul team, is a change of direction. And it really doesn't offer us any mechanical advantage. It's simply a convenience as a change of direction. Okay? Another way to think about this, any leg of rope that goes from an anchor, myself as a haul team in this scenario, I'm part of the anchoring system. So any leg of rope going from an anchor to an anchor offers no mechanical advantage. It's only these legs of rope that go from anchor to load that give us the lift and the mechanical advantage. Change of direction, rule number 3. Let's look back here again. Rule number 1, if it's at the anchor, it's always going to be even. Rule number 2, if it's at the load, it's always going to be odd. Rule number 3, the last pulley at the anchor is a change of direction. Okay? Rule number 4, and we can stay right here. Rule number 4 states that you can count the number of pulleys, add 1, and that's going to tell you what the mechanical advantage is. So let's pretend we don't have this CD here, and I'm just going to haul from right here. And we have this 3-to-1, a Z-rig. I have 1, 2. I add 1, and it says I have a 3-to-1. Another way to look at this is I have 3 legs of rope going from the anchor system to the load where this pressic is. 1, 2, 3. I'm pulling on 1, and I have 3 working for me, hence the 3-to-1. Okay? Our last rule, rule number 5, states a simple pulling on the haul of another simple mechanical advantage becomes compounded, and you multiply those two. So what do we have here? We have this blue rope that's an obvious 2-to-1, and it's pulling on the end of what we have rigged here is a 5-to-1. How do I know it's a 5-to-1? Well, let's go by our other rules. It's tied off at the load, so I know it's going to be odd. I have how many pulleys? Well, I have a double sheave right here, so there's 1, 2, and I have another double sheave up here, 3, 4. I have 4 pulleys. Add 1, that says it's a 5-to-1, okay? I can also count the legs of rope between the anchor and the load, and I have 1, 2, 3, 4, 5. So all my other rules are incorporated right here as well. This is a 5-to-1 if I were to pull from right here. But say this is just not giving me enough power, and I'm really getting wasted. I need more horsepower on this thing. So I can quickly add a 2-to-1 represented by the rope here. So I have the 2-to-1 multiplied times the 5-to-1. This is a compound 10-to-1. What's the trade-off? Nothing in life is for free, is it? The trade-off is I have to pull 10 feet of rope here to move that load 1 foot. But it's relatively 10 times easier, discounting any of the friction and stuff within these pulleys themselves.